And peers, this is Dr. Jones checking in. This is video lecture 1 for lecture test 1 in AMP 2. Yeah, I think I covered all that. Del Mar College with Dr. Jones. So I am recording this for an online only course, but we may need it some other times. So I will not be doing any class updates in these lectures. I'm trying to keep these videos to lecture material only. Okay, so the first thing you are going to need in order to follow along is your note set, which is on Canvas. Note set, lecture test 1. And I got 3 videos in before I realized they were recording with no audio because it was a different button, and yeah. So I've already done all of this and I'm starting over because I messed it up. So such is life. But I had an old version of the note set. So I have printed a new version of the note set, but it is not filled in. But right now we have the light for the recordings. So we're going to do this, and is a redo anyway. So we're moving on. Okay, let's see if I can get the next page. There we go. Okay, so we are working in, let me turn the laser pointer on so you can see what I'm pointing at. Martini 11th edition, but previous editions will also work. International editions, it all works, it's fine. I've even had people use different anatomy and physiology books that weren't Martini. And I mean, it's anatomy and physiology, it's kind of all the same. So, but the page numbers will be wildly different and the material will be in different orders. So it depends on if you have more time or more money. The Wood Lab Manual I do recommend because it's awesome and more conversational than our lecture book and way easier to understand, especially in the physiology sections. So anytime you're stuck in the Martini and you don't understand the physiology, like cardiovascular, respiratory, I recommend you open our Wood Lab Manual and read the section there. My favorite coffee mug, as I've already told you today, but it didn't record the audio, so you had no idea what I was talking about. And I have cinnamon. I put cinnamon in the coffee today, so so good. Breakfast of champions. Okay, and then you do need the 2402 lab book. I think this might be an older version. There we are. We're in the screen now. Okay. And that is my email address for my students if you didn't already know. Also, I have lab videos here on YouTube. I'm searchable under Dr. Jones 32, and there are Quizlets that are a few versions of the book ago. So some of the terms have changed a little bit. But there are Quizlets and they are searchable under Dr. Jones 32 also. So Dr. Jones 32, no spaces, and that's my email address at rjones32@delmar.edu. So there's that. Okay, and do stuff. I do require that you read the book and fill in the note set. For test 1, we're doing parts of chapter 15. We did most of chapter 15 in 2401. We skipped the very beginning of it. So we're going back and picking up those few sections at the beginning of chapter 15. And we're doing chapter 17, which is special senses. So definitely read the Martini and fill in the note set. If you haven't had my 2401, my note set is pretty much directly out of the book. And our lecture PowerPoints that I lecture off of are directly out of the note set, so we pretty much follow the book. Again, I am lecturing off of a blank note set because I just printed it because I realized my filled-in note set is a previous version, so I'm doing the note set juggle, and we'll make it work. Okay. Oh, and everything else is on Canvas. It's on Canvas. Yeah. So your tests are on Canvas. Your lecture tests are on Canvas. The extra credits are all on Canvas. So I don't want to get too far into that because I want this to be applicable to all semesters, but go through your Canvas. Okay. All right, so let's start with the difference between general senses and special senses at the top of page 2. Page 2. Okay, so general senses monitor the body and your environment. So anytime I use the word monitor, you know automatically that I'm talking about sensory, because motor doesn't monitor, motor moves. It's different. So body and environment, this includes your temperature, pain, itch, pressure, touch, vibration, chemoreception, and proprioception. And yes, I am going to go a little faster in these videos because since the videos, you can pause them and go back and watch it again. So yeah. That, and without you here in front of me, I have no idea how long it takes you to write things down. So we're mostly just going to keep moving. Feel free to pause, rewatch. It's your video. You do what you need. Okay. The general sense receptors are simple in structure and they're everywhere. And the information goes to your primary sensory cortex. Next, let's talk about the special senses. Special senses include, let me get on the screen here, smell, vision, taste, balance, and hearing. Now, in kindergarten, you learned 5 senses. You learned smell, vision, taste, touch, and hearing. Touch is a general sense. It is not a special sense. So you have 5 senses in screen. You have 5 senses. Touch is not a special sense. It's a general sense. And then you have 5 special senses, which is weird math, but okay. We're going with it. So the special senses, the receptors are all quite complex, unlike the general senses, and they are all located in sense organs. So smell, vision, taste, and balance and hearing are both in your inner ear. And the evolutionary movement of all of the special senses to the head is called cephalization. As you recall, the cephalon or cephalic region means the head. Okay. And the special senses all require quite a bit of processing. So we'll have, that's why we had in 2401 in the neuro, the association areas in the brain, which are even larger than the areas like the gustatory association area is larger than the gustatory cortex. So they all require quite a bit of processing. Okay, let's change slides. I think the arrow on the keyboard works. Boom. Okay, so blank are a series of neurons that relay sensory information from the sensory receptors to the CNS. And those are sensory pathways, a series of neurons that relay sensory information from the sensory receptors to the CNS. So the pathways are literally just the neurons that the information travels on. The CNS consists of the brain and spinal cord. The peripheral, stands for central nervous system. The PNS stands for peripheral nervous system, as a review. And it consists of the peripheral nerves. There are 2 types of peripheral nerves, the cranial nerves off of the brain and the spinal nerves off of the spine. So that's the peripheral nervous system. Specialized cells that monitor conditions in the body or external environment are called sensory receptors. And the parts of the brain that receive somatic sensory information are sensory processing centers. Okay. Next, arriving sensory information is called a sensation. And your conscious awareness of that sensation is called a perception. So a very small percentage of sensations turn into perceptions, and we'll talk about that when it comes up in the book. General senses monitor our sensitivity to, and here's your list: temperature, pain, touch, pressure, vibration, and proprioception. Special senses include olfaction, and what's the technical term for olfaction? Smell. Vision, a technical term for vision is, well, vision is the technical term for sight. Well, that's not the order in the note set. The order in the note set is smell, olfaction; taste, which is gustation; sight, which is vision; balance, which is equilibrium; and hearing is the technical term for hearing. Special sense receptors are located in sense organs: eyes, ears, nose, tongue. And the translation of an arriving stimulus onto an action potential is called transduction. So this will be like when your cell phone takes your voice, your sound waves that are you talking, and transducts them, translates them to cell phone waves, and blasts them out in all directions. A quick phonics note. I have learned in the first 3 videos that I'm deleting because they had no audio, that if I hit up and W, oh, I see. So if I just hit up without the W, it changes the slide. That's what happened. Okay, so I wanted to have a quick phonics note for y'all. And I am writing with the mouse, which is terrible, and I apologize. I did try a thing and the trackpad, and it was equally terrible. And it's not a touchscreen. It's an old computer. It's not a touchscreen. Okay, so quick phonics note. A G with an E, an I, or a Y after it says the soft J sound. A G with an A, an O, a U, or a consonant, let's make that an L, make sure it's not an I, makes the hard G sound. So G-E, G-E, gem. G-I, giant. G-Y, gem. Gem, giant, and gem. As opposed to G-A, gate. G-O, got. Gut. And let's go with glue. There we go. Glue. It's an adhesive. If you've heard me tell that story. If not, glue is still an adhesive. So it's the same with C. C with an E, an I, or a Y after it makes the, I'm off screen again, the soft S sound. And a C with an A, an O, a U, or any of the consonants. Consonants, anything that's not a vowel. The vowels are A, E, I, O, U, and sometimes Y. C, E, like, I don't know, ceiling's kind of all I got for this one. C-E-I-L-I-N-G. C-I like city, and C-Y like cycle. So you see how this C has a consonant after and it says k, not s. And then cat, caught, cut, and why not go with clue, because that's fun. Okay, so this is why G-U for taste is gustation, and G-E for pregnancy is gestation. Gestation? Gustation. Gustation is taste, gestation is pregnancy. So a little phonics helps us understand a lot of the Latin terms and how to pronounce them. So there you go. Okay. We were here. Primary sensory cortex. No, we did this. We were talking about transduction, and we had just said that gustation was taste. Okay. Did we finish? We finished page 2 of the note set, so we're going to flip to page 3 and talk about receptor specificity. Receptor specificity, oh, I need to flip both note sets. I had a filled in note set. I don't know if it's at my desk at school that I can't get to or what. In case you're curious, I'm recording this during COVID, so that's why I'm recording. Otherwise I wouldn't, but now we are. So now we have these, we can use them. So receptor specificity is that each receptor only reads certain stimuli. So a taste receptor will not tell you that it has just seen a photon. It can only taste things. Your eyeball, your retina, can only read, I'm off screen again, read photons. So if you get hit in the eyeball, that pressure, you have no pressure receptors on the retina, and so that reads as a bright light. And so that's why. So that's why is the tagline for 2402. So that's why. You're going to hear that a lot this semester. Lots of explanations of things that, oh, that's why. The area monitored by a single receptive cell is a receptive field. And let me switch back to my laser pointer and you can see what I'm pointing at on the slide here. Handy. So here's a sensory receptor, and this is the area that it innervates, and that's the receptive field. So if you touch here, that activates this sensory neuron. Sensory neuron number 2, receptive field number 2, touch here, and it activates this sensory neuron. So those are the receptive fields. And the receptive fields are smaller in areas like your fingers and your face, and much, much larger on like your back and like your legs. Action potentials. Is this the next slide? Sort of. Oh, I'm on the wrong note set again. Okay. Area monitored by single receptor cells, receptive field. A receptor potential? No, yes. Receptor potential is the change in the transmembrane potential of a receptor cell, and I'm off screen again. So in many of our special senses, we will have a receptor cell, and I'm on the pointer, so you should be able to see this. A receptor cell and a synapse, right, with neurotransmitters and that whole shebang we talked about with neuro for last semester, and a sensory neuron. So the receptor cell can have a receptor potential when it is activated by a stimulus. And this can be depolarizing or it can be hyperpolarizing. So a receptor potential, back on the note set, top of page 3, fill in the blank, receptor potential, is a change in the transmembrane potential of a receptor cell. It can be a graded depolarization or a graded hyperpolarization. The generator potential is in the sensory neuron, and it generates action potentials. Okay, and I'm going to white screen us. Actually, let me find my phone and check our time. I have a timer going. I forgot to hit start because I was waiting until I actually got the video, and then I was, yeah, I have no idea. There's no, yeah, I don't know. Okay, well then let's talk about the difference between depolarizing and hyperpolarizing by going to white screen but without changing the slide. Boom. No, it didn't do anything. Let's try again. Okay. I have to hit the up and then the W, but when you hit the up, it changes the slide. Okay. Back to the pen. Booyah. And I haven't found any kind of like text. That's not what I wanted. Oh, did it just type in what I said? Booyah! Evil laugh. I wonder if that's even in the screen. Okay. Going with it. Uh-huh. I pulled up a white screen to tell you something important. Okay. Are we in the pen? We're on the pen. All right. This is a cell, in case you couldn't tell. Inside the cell, there is a lower concentration of sodium ions than outside the cell. Sodium, sodium, sodium. Okay. In no way are you to believe that that is a 3-to-1 ratio of sodium outside the cell to inside the cell. I am simply showing there's more outside the cell than in. Now, when you open a sodium ion channel, because of the concentration gradient, the fact that there's more outside than in, which is also called the chemical gradient, the sodium diffuses in. Also, there's the fact that the cells are relatively negative inside and relatively positive outside. I wonder if it'll let me edit this screen thing. Okay. This difference of charge between the inside of the cell and the outside of the cell is the transmembrane potential. Transmembrane potential. A change in the transmembrane potential is an action potential. Okay. I still feel the need to type it in. Transmembrane. Yes, my handwriting's bad anyway, but writing with a mouse is always terrible. So the transmembrane potential is the difference in charge across the membrane, the fact that it's relatively negative inside the cell and relatively positive outside the cell. What makes it relatively negative inside the cell is largely the presence of proteins inside the cell, in the cytosol of the cell, that are not in the extracellular fluid. So the negative charge inside the cell is a second reason that the sodium, like fools, rush into the cell. I'm going to change to blue now. Pen color. Ooh, we're going with cyan. Potassium. Is found in higher concentrations inside the cell than outside the cell. So when you open a potassium ion channel, the concentration gradient is strongly pushing potassium out of the cell. But since potassium, like the sodium, I don't know if you can see my pencil when I'm not writing, but the potassium, like the sodium, is a positive ion, a cation. And so because the inside of the cell is negative, it is being moderately, or slightly, pulled back in. I have stolen from my children some magnets to show this type of interaction. These ions are not magnets. Okay, so what happens if you get two negatives together? Nothing. They will repel each other. What happens when you get two positives together? They will repel each other. Negative and positive, boom, they're attracted. Opposites attract. In magnets, cations and anions, And that really terrible Paula Abdul song with the video with a cat. Do you remember that one? That was weird. But there you have it. Opposites attract. Because magnets. Okay, so when we add the electrical gradient and the chemical gradient, we get the electrochemical gradient, and potassium will be moderately pushed out of the cell. Let's go back to red. And sodium will be strongly pushed into the cell. So if we draw our transmembrane potential, and we'll say that's negative 70 millivolts, which is our standard transmembrane potential. And to be clear, negative 70 is less than 0. So plus 70 would be an equal distance above 0. So we're at negative 70 millivolts, which is less than 0. This is like negative 70 millivolts is like when you owe 70 bucks on your Kohl's card. Not only do you have 0 money in your Kohl's account, you owe Kohl's $10 or $70. Okay. So any time you open a sodium ion channel, positive ions rush into the cell. That makes the inside of the cell less negative. Now, it's probably not going to make it positive, but it is going to make it less negative. It's going to bring it closer to 0. And this is called depolarization. D-E-P-O-L-A-R-I-C-A-T-I-O-N. Depolarization. I'm looking at how they spelled that on the screen, and that is so weird. Okay, so then once that channel closes, it goes back to resting membrane potential, which is your negative 70 millivolts. Now let's say, I'm going to change back to cyan, that we open a potassium ion channel, and that's going to cause positive ions to leave the cell, making the inside of the cell more negative. And the difference from 0 is the polarization. So this is going to make it even further from 0, which you recall is up here. So this is called hyperpolarization. Hyper polarization. Yay. Hyperpolarization. And then once that membrane channel closes, it goes back to resting membrane potential, which is our negative 70 millivolts, which again is lowercase m and capital V. Volt was the dude's name. So you capitalize it, that's called a proper noun. Is that what I wanted to tell you? Inside of the cell is relatively negative compared to the outside of the cell. Okay, so to review, there are a number of super important concepts covered here. Number 1, the inside of the cell is relatively negative compared to the outside of the cell. This is need to know information. Number 2, anytime, and any living being that you open a sodium ion channel, sodium, like fools, rush in. And that makes the inside of the cell less negative, which is called depolarization. So that's number 2. Number 3, anytime, and I mean anytime, in any living being, that you open a potassium ion channel, the potassium will rush out of the cell. And it's also positive, So when you lose positive and you're already negative, you get more negative. And that's called hyperpolarization. So every time you open a sodium ion channel, depolarization. Every time you open a potassium ion channel, hyperpolarization. Okay. All right. I think we're still here. So this would be maybe negative 80 millivolts. So if you owe $70 on your Kohl's card and you go into Kohl's and you buy another $10 shirt because, hey, it's a $10 shirt. Who couldn't use another $10 shirt? And you put it on your card, you have hyperpolarized your card because now you owe $80 on your Kohl's card. But let's say instead of doing that, I turn my color back to red. You go into Kohl's, assuming you're doing this at a time when you can walk into stores, and you pay $10 on your Kohl's card, then now you're at, let's say, negative 60 millivolts. So you have depolarized your Kohl's card. You still owe Kohl's, but you owe less than you did before. Okay. That's your math with Dr. Jones on how to negative numbers. Okay, let's up W and go back. That did not work. Oh, it did work when I wasn't looking. Ooh, oh, just up did it. Okay, we already had the screen. And we had that screen. Okay, so I am going to call it here. Let me find a Post-it. I had a thing of Post-its out, like the big, there they are. They're under the other Post-its. All right. We made it not super far, but we got some super important concepts in. So this has been ANP 2, lecture test 1, video 1, and we covered Noteset pages 2 and started page 3. 2 and 3. Okay. And I have a Post-it here showing where we will start for the next one. So again, this has been Dr. Jones this has been a video lecture for AMP2, lecture test 1, video 1. Thank you as always. This is our first one. Thank you for tuning in. There are lab videos on YouTube. They are public. You don't need a link for those, although there are links in Canvas. You can search them under Dr. Jones 32, no spaces. There are matching Quizlets, and those go with searchable. Dr. Jones 32, no spaces. All right. So thank you again for tuning in. The education must go on. Dr. J out. And now I have it on a Post-it. Command, Control, Escape, and that will stop the recording. The window button is the command, and that's the control, and the escape's over here. So have a good one.